Let's quickly see some more examples of doing data analysis using Excel. And for that, we can use some inbuilt add-ins which can be added to our Excel sheet. So for example, if you would want to do a descriptive analytics or descriptive analysis on your data, say for example, getting your descriptive statistics such as your mean, median, mode, and so on. So we can do that and we can use Excel for it. So for example, you can, if you are given some data, say I have temperature, price of ice cream, units sold, and I would want to have descriptive statistics on this, what I can do is I can click on File, and here in File, you can click on Options, and within Options, click on Add-ins. Now, within Add-ins, you have Excel Add-ins, which is selected here. So click on, say, Go, for example, and that shows what add-ins are available, and you can choose which ones are you interested in. So, for example, I have chosen Analysis Tool Pack and Solver Add-in, and click on OK. Now that basically should add more options to your Excel. So if you click on data, so here you see data analysis and solver. And this is what we would want to use to get our descriptive statistics for these three columns. So for example, let's say temperature, or you can even give the names later once you get your descriptive statistics. So for example, let's go for data analysis. And here it says, what are you interested in? There is a two-factor with replication. You have correlation, covariance, descriptive statistics. You have histogram. So let's click on descriptive statistics. Click on OK. Now this one basically asks your input range. So while your cursor is blinking here, also it is said grouped by. So let's give it a range. So for example, I will say temperature. Now, if I do this and I have selected the heading, just look at that. And now you need an output range. So let's just select this. And then you can have your cursor blinking in here. Let's select, say, fields here. And this is where I would want the output. Now, it also said what options do you want? So it has output range. We can then select summary statistics, confidence level. So I will say summary statistics is what I'm interested in. Say OK. And this says input range contains non-numeric data. Now, why is that? Because we chose temperature, the heading also. So click on OK. And here we will alter the range. So this one is our range should be only the values, numeric values on which we would want the descriptive statistics. We have output range already selected. We have summary statistics. And now you can click on OK. And that basically gives your descriptive statistics for temperature. So here I could basically give in a value for this. So I can say temperature, and that's my descriptive statistics for temperature. Might be I can just do some formatting, and that's it. So that gives me descriptive statistics for the values here. Now, similarly, we can do it for price of ice cream. So what we need is we need to basically go for data analysis, descriptive statistics, say OK. Now you need to give a range. So here I will change my range to these values. Output range is already selected. Now we are interested in summary statistics. Click on OK. And this says output range will overwrite existing data. Press OK to overwrite data in range. I will say cancel. No, that's not what we want to do. We need to give a new range. So let's select our new range, which is here. And now click on OK. So now we get the values, which is for your price of ice cream. So again, we can basically select this and say price of ice cream. And we got our descriptive statistics for price of ice cream. And like we did earlier, I can select this. I can basically do a merge and center. and that gives me descriptive statistics for price of ice cream. So we could also basically change this. Now I can go into data and I can go into data analysis, descriptive statistics. So we know that we had selected this B2 to B8, and this one, which is H6 to H19, we would want to shift it, might be 2 columns up. So might be I can just say H5 and I can manually change it to H17, and let's say OK. And we will basically get this, and I can get rid of this. So I can have it in the same range. So similarly, so this one will have to be renamed, and I can basically say price of ice cream, and that's basically my descriptive statistics for my price of ice cream. And similarly, we can do it for the third column, which is units sold. So we would want to have this. Now let's see, we can click on data. We can click on data analysis, descriptive statistics. So we need to give the range correctly. So this time our range changes to units sold. Now we can also say labels in first row, okay, if we were selecting the heading. So let's do it in this way. So in my range, let me empty this. I can basically select this, which we know has non-numeric data in the first row. Say, for example, I'll say labels in first row. I'm interested in summary statistics. And this range will now have to be changed from H to basically something like J. So let's say J. And let's select these values. So that should take care of things. And now you see, you have your units sold. You did not have to manually rename it. And you have basically got the descriptive statistics. So this is how you can simply perform analysis using data analysis here. You can basically get your descriptive statistics for your columns, and then you can do whatever needed formatting you need to basically make your data look in a good way. Now, let's look at one more example of data analysis where we may want to look at the frequency of values or frequency of values occurring in a range of values. So for example, if you have been given temperatures, you have been given some bins where you would want to identify how many values fall into the range of 0 to 20, 20 to 30, 30 to 40, 40 to 50, and the easiest way to do that would be creating histogram. Now, histogram is usually used for data analysis where you would want to look at different variables or say features. For example, temperature is one such feature. Might be one more variable or feature such as sale of ice cream, and you would want to see if the increase or decrease in temperature affects the increase or decrease in sale of ice cream. Might be sale of ice cream is a response based on temperature. So it depends. So sometimes you may want to find a relationship between two variables, whether they are positively or negatively related, or you would want to do different kind of analysis. And in certain cases, we may want to first do analysis on one single variable, look at the frequency of values, might be also look at the defects, and for which we can use something like Pareto chart. So we can go for histogram, and that basically gives us the frequency of values. Now, how do we do that? So we have already added the add-in, which is data analysis earlier. So we can just use the same thing again. Here, we would want to create a histogram. So let's say, okay. Now, I have already selected input range. So if you see here, my input range is temperature, which is also with the headings. And I have bin range, which is basically the range of values. So for example, I can select this, and that's my bin range. I am selecting or the option labels because I'm using the first row which has the heading such as temperature and bins. Now we need to give an output range. So for example, let's say I would want my data here, and that becomes my output range. So you can have a sorted histogram or basically a Pareto chart. So if that's what you're interested in, looking at the frequencies for your different ranges. And here I'm also selecting chart output because I would want to have a visual histogram which gives us the frequency. And it's as simple as this. Just click on OK. And now you get your bins. So it basically tells you frequency of values, which is basically 20, but that does not mean it is only talking about the values 20. It is basically talking as a range of 0 to 20. So we have 0 to 20, that is 2. So we can basically say there is 120 here, with the 20 being the maximum value, and then there is one more 20. So that's your 0 to 20. Then you have 20 to 30, which shows 3 values. So might be in that case, I can say 26 is one thing. Then I can say 30. That's the second one. And then basically I can look at 22. So basically this one does not select 20 as the lower range, but it basically selects 30 as the higher range. So I do see 20 to 30, there are 3 entries. Similarly, we can see values for 40 and 50. And since we have selected Pareto or sorted histogram that shows in a descending order, what is the highest frequency of values within a particular range. So that shows me highest frequency is 5. And then you have 3 and 3 and then 2. So this is how we can create a histogram and we can perform analysis on a single variable. Now, as discussed earlier, as I said, sometimes we may be interested in finding out the correlation between different variables, such as say here we have temperature, price of ice cream and units sold, and we may want to find out the correlation between one variable to another variable, or we would want to find out the relationship between variables. Are they linearly related? Are they positively related, negatively related, and so on? And for that, we can use the correlation of your data analysis add-in. So for example, you want to find out correlation of temperature and units sold. And what we can do is we can find out that using a formula. So for example, if I search for something like correlation, and let's search. So there is a function called correlation which we can use, and we can use this to calculate the correlation of temperature and units sold. So for example, let's select this, and that's the function. So it says give me a first array and a second array. So we are interested in finding out correlation of temperature and units sold. So let's select the range of values for temperature, and then I'm interested in finding out the correlation of temperature and units sold. So let's select this, and that basically gives me a range of values. It gives me the correlation value, which is 0.2859. Say OK, and that's your value. So similarly, we can do it for temperature and price ice cream. So let's go for correlation. So that's the function we are interested in. You need to give a range of values. So here we are interested in temperature and price of ice cream. So let's select temperature. And then the second array or list of values is price of ice cream. Let's select that. Let's close our bracket. And here we have the correlation value of temperature and the price of ice cream. Similarly, you may be interested in finding out temperature and units sold, like what we have done earlier. So we can do the same thing based on function. So this is same as correlation of temperature and units sold. So I can get rid of this one. Now, how do I do it using the data analysis add-in? So for that, what we need is we need to go into data. We need to go click on data analysis. And here you have the option called correlation. Let's select this. Now that basically needs an input range. So we need the range. Now I might be interested in finding out the correlation between temperature and price of ice cream and units sold. So I've selected all the columns here. we will say group by columns. Obviously, we need to select labels in first row because that is basically taking care of the first row is heading. Now output range, you can just give one simple cell and that's where your data will start from, or you can give a new workbook. So click on OK, and that basically gives your correlation of your different variables and what are the values. And we can check these values based on the values what we have here. So we have basically temperature and price of ice cream, and that basically shows me 0.96149. You have temperature in units sold, so you have 0.2859. Now you can also look at units sold and say, for example, price of ice cream. You can look at these particular values. So if I would be interested in finding out what is the relationship between these variables, I can easily find using correlation. So I could be basically writing in a formula here and selecting what are the cells. So here we were selecting A2 and C. Here we were selecting A and B. Now might be I'm interested in price of ice cream and units sold. And if that's what I'm interested in, then I will give a range of B2 to B8, C2 to C8. And similarly, you can get your analysis or correlation values. So it's very simple in Excel, and you can use either the data analysis tab and get your correlation, or you can use formulas and do that. Now, one more important part of data analysis is doing your sampling. Now, sampling could be periodic sampling or random sampling. So sometimes you may want to look at a variable and you may want to get some values based on periodic data. That means might be I'm interested in the range of values. I'm interested in seeing a sample of values for a particular period, which could be basically a range of values, or you could just do a random sampling. So for example, if I go for periodic sampling, so out of these values which I see here, might be I want to see, say, periodic sampling, that is a frequency of 2 values, how many times we have these values occurring here. Or I would go for random sampling. So basically randomly, I would want to pick up, say, 3 temperature values. Now, how do I do it? So for example, here I have 7 values. Now, if I go for periodic sampling, the sample or periodic sample value which I need to give has to be lesser than the total input values. So for example, we can do this. Let's go in here and let's go for data analysis. So we can go for sampling here, click on OK, and that needs a range of values. So we will select A2 to A8. Now I could have selected all the values for this one, temperature, and in that case I can give labels, which is going to take care of the first row. Now here we can go for number of samples which you are interested in, or giving a period. So let's go for period and say, for example, I have 7 values. So what if I select 5? So for example, if I say 5, that means I could just get 1 value. So basically when I'm saying 5 out of 7, so that's just giving me out of 5, I want 1 value. So I can then just give an output range. So here I can basically select this cell. I'll say OK. And now you see it just shows me 1 value. So out of the first range, that is I've said 5, it has given me the 5th value. That's your periodic sampling. So for example, we want more values. So let's reduce this period to might be 2, which basically gives me every second value. So I can basically say, for example, 2 and say OK, and then say OK. So that shows me 26, then you have 35, then you have 40, and then, well, this one does not have any more values. So that's your periodic sampling. Now, if you go for random sampling, that's basically randomly picking up values, and you can choose how many values you want. So go for data analysis, go for sampling. I'll go for number of samples, how many you want. So for example, out of 7 values, randomly, I want 3 values, and I can just give this, say okay, and then we will do a cancel because we need to change the range. So let's select this and say okay, and that gives me random 3 values from this values of temperature. So we can use Excel to do a simple sampling, and we can choose whether we would want to go for periodic sampling or random sampling. Let's continue learning Excel and how Excel can be used for data analysis. Now we have seen sampling, histogram, correlation, descriptive stats, and now also let's look at regression. Now what is regression? So when you talk about statistical modeling, regression analysis is used to estimate the relationship between 2 or more variables. And basically we would want to look at 2 or more variables and basically a relationship of those variables with the response or the target, right? So for example, if we look at our data here, we have temperature, we have price of ice cream, and then we have units sold, and we can go ahead and make predictions. So for example, when you look at regression here, you see something like this, which is regression statistics. You have ANOVA, you have different plots, which we have here, which is x variable 2, and then you have normal probability plot. Now we have already seen how you can have your add-in, that is data analysis, which helps you in doing different kind of data analysis here, right? Now, how do we do this? So we have our variables here, which is temperature, price of ice cream, units sold. And when we talk about regression, we need to understand which one of these are independent variables, which one of these are dependent variables, right? So when you talk about your X, that's your independent variable, or we can say predictor or explanatory. So when you talk about your independent variables, or as we say predictors or explanatory variables, these are the factors that might influence the dependent variable. And when you talk about dependent variable, that's your response or target. That's the main factor you're trying to understand or predict. So we can plot a scatter plot to see relationship between variables. If they are linearly related, are they positively related, negatively related, and so on. We can also get values such as R square, which is coefficient of determination, regression line, and then analyze the relationship between variables. So here is one of the links of one of my other videos where we are learning on machine learning and also on regression, but that's programmatically and using a processing framework such as Spark. Now here, let's see how do we do this in Excel. So basically we would want to use our variables, which is temperature, price of ice cream, units sold, and then get these plots. So what we can do is, for example, I can get rid of this, and might be I can just say no borders. And when it comes to these plots, we can have them generated again. That's not a big deal, using your data analysis add-in tool. So we have been given variables here. Now, as I said, when we talk about your regression analysis, we need to understand whether we have one variable or we have multiple variables, right? So you might have heard of univariate analysis, bivariate analysis, and so on. Well, here we are focusing more on using Excel to do our regression analysis. So I'll not go deeper into regression topics, but certain things as basics should be known, that when we talk about regression analysis, what does it do? It helps you understand how the dependent variable changes when one or more independent variables vary. And It basically allows us to mathematically determine which of those variables really has an impact. So technically, when we talk about regression analysis model, that is based on the sum of squares, which is basically a mathematical way to find the dispersion of data points. So mainly the goal of the model is to get the smallest possible sum of squares and draw a line that comes closest to the data. So that's what we mean by our regression line, or basically looking at the points and seeing if the points fall on a regression line, if there are residuals, that is points which do not fall on the regression line. And in terms of statistics, when we talk about statistics, we differentiate between a simple and multiple linear regression. So you have something called a simple linear regression models, which basically gives you the relationship between dependent variable and one independent variable using a linear function. And if you use two or more variables, that is explanatory variables, to predict the dependent variable, we are actually dealing with multiple linear regression. So if the dependent variable is modeled as a nonlinear function, because the data relationships do not follow a straight line, we have to use nonlinear regression. Now, what we will do is we'll see how we can work on this. So here we have some variables, and if we look at this, might be based on temperature, price of ice cream, we would want to find out how many units were sold. Now, what we can do is we can basically start looking in by creating a simple scatter plot, which is quite easy in Excel. So if you have been given variables, what you can do is you can click on insert. You can then choose the kind of plots which you want, and here you have insert scatter plot. So we can choose this, and you can choose the first option. So that gives you a blank layout. And what you can do is now you need to select data. So for example, let's click on select data, and then you can say add. So what we would want is we can give a name. So we want X values and we want our Y values, right? So when you talk about Y, that's your dependent variable or your response or target. So that is in our case units sold, and X values are one set of features or variables or multiple variables. So here I can click on this series X values, and then I can select this. Now in Y values, what I can do is I can select these, and then I can just say OK. So that shows me that it would be giving me a regression scatter plot. Now let's say OK, and we have some points plotted here. Now, if you would want to see the impact of one individual variable, such as temperature or price of ice cream, you could as well do that. Now, what you can also do is you can add more meaning to this by giving it a title, or you can also go into quick layout, and you have various options here. So you see, it gives you what is the access title, what is the series, and I would prefer to use here something like this one. So that gives you your regression line, that also gives you your R square, and that gives you your Y and X, that is your coefficients. So let's select this one, and then we have some values which we can use to compare. This also shows me the regression line. And you can keep this for reference. If you would want, you can change the chart title to something else, say scatter plot of dependent versus independent variables. And you can give any name which has more meaning. And we can get rid of this one. So we have series, and we can say, what are these points? If you would want to add in legend, if you would want to do that, or I can just get rid of this, and I will keep these values here, which we will see when we do a data analysis. We can always compare these values. So here I've created a simple scatter plot, and then I can look at dependent versus independent variables, or I could have selected one particular variable. So this is just for reference. Now we can add more details. We can say, what is my x-axis, what is my y-axis. So basically you can here say, for example, just say y, and might be here I will say x, and we can rename that later. Now, how do we perform data analysis or get into regression, right? Now, what we would want to do is we would want to do the regression analysis to demonstrate the relationship between dependent and independent variables. So normally when you talk about your linear regression equation, you might have known about it. So it is basically y, when you say y equals, you can say bx plus a plus c, and this would be normally the mathematical equation for a linear regression where x is your independent variable, y is your dependent variable, your a is the y-intercept, which is expected mean value of y when all x variables are equal to 0. So basically on a regression graph, that's the point where line crosses the y-axis, and that's your intercept. When you talk about b, that's basically your slope of regression line, which is the rate of change for y as x changes. And then you also have your constant, right? So that's your, that's basically your random error term, right? Which is basically the difference between the actual value of dependent variable and its predicted value. So your linear equation always has an error term because in real life, predictors are obviously never perfectly precise, right? Now, what we can do is we can also reduce this equation to y is bx plus a, and that's the equation of a line. We can look into this, and the linear equation can be understood mathematically in this way. Now, how do we do it in Excel? So what we can simply do is, here, let me, here. So we need to get into data, and then here we have our data analysis add-in. You can click on this one, and from these different options, you can choose regression. So that's what we would want to do. Now we'll say OK. Now here you need to give your input Y range. So as I said, you will have to select the dependent and independent variables, right? So we would want to do some regression analysis here. And here we have your X and Y. So Y being your target, that's basically your units sold. So we can select this along with the labels. When it comes to X, either you can select one variable or multiple variables. So I will select temperature, price of ice cream. And then since we have chosen the headings, we will go for labels, right? Now we can always look at the confidence level. We can change that. So you can say whether you want it in a new worksheet or you can just say output range. And I will probably just click here and select one of the cell here. Now we can also choose the other options which we would want to see as a part of this regression analysis. So basically we have selected input Y range, which is your dependent variable. You have selected X range, which is your independent variable. And if we are building a multi-regression model, then we have chosen temperature and price of ice cream both. Now we can choose the labels which we have done. We can choose your output range, which is basically on this sheet. And then we can select the residuals. So that basically gives you your residuals. Now we can also get your line fit plots, which you were seeing earlier. You can also go for your normal probability plots and then basically just say OK. And let's say OK. And that basically gives you your regression analysis output. So we basically have your summary output. We also have ANOVA. We have our residual output that's from the previous one. And basically we can get rid of this. That's not required. I can get rid of this one. Yep. So now we have our regression statistics. We also have our plots. So we can basically look into these. So we have our normal. Let's get rid of these. Let's get rid of this. Let's get rid of this. And then what we can do is, since we had some existing data, it has overwritten. So let me get rid of this and I'll repeat this step again. And let's say no border. Yeah. So now what we want to do is we want to do regression analysis. So we go get into data. We get into data analysis. We choose regression. We have already chosen our Y range, which is column C. X range is multiple variables. We have gone for labels, output range, which we would want to select a particular cell. So let me select this. I'm going for residuals, line fit plots, and normal probability plots, and say OK. So now we have our plots. We can just separate them to have a better understanding. Yeah. And that basically shows you the variables. So here it shows me units sold, and then what are the predicted units sold. And here the variable is temperature. Here the variable is price of ice cream, right? So that's your one variable and second variable. And then you also have your normal probability plot. Now to interpret this or to understand what we have here, where we look at your summary output. So it is good to understand what Excel is helping us out. So basically, when we do a regression in Excel, it is performing all the calculations automatically. The interpretation is something which we need to understand. So basically, we are looking at multiple R value here, and we can, let's also fine tune this one. Yeah. We have our values here, and if you see, we have our R square. Now, we can then basically look at our multiple R. So what is your multiple R? That's your correlation coefficient, which basically measures the strength of linear relationship between two variables. So this can be any value between your, when you talk about your correlation coefficient, it can be any value between -1 and 1, and its absolute value indicates the relationship strength. So the larger the absolute value, the stronger the relationship. So 1 basically means a strong positive relationship, -1 means a strong negative relationship, and 0 means no relationship at all. Now when you're looking at R square, that is the coefficient of determination, which is used as an indicator of the goodness of the fit. So it basically shows how many points fall on the regression line. So your R square value is basically calculated from the total sum of squares. When we say precisely, it is the sum of squared deviations of the original data from the mean. Now, when we talk about looking at the value of your R square, so it is basically, we can be seeing that this is 0.450788. That's the value which I'm talking about. So it basically means 45% of our values fit the regression analysis model. So in other words, 45% of dependent variables, that is your Y values, are explained by the independent variables, that is your X values. So normally if you have R squared value higher, then that is considered as a good fit. And here we have considered multiple variables. Now when you talk about your adjusted R square, it is the R square adjusted for the number of independent variables in the model. So you would want to use this value instead of R square for shows the precision of your regression analysis. So the smaller the value, the more certain you can be about your regression equation. So when we talk about your R square, that represents the percentage of dependent variables variance that is explained by the model, and standard error is basically an absolute measure that shows the average distance that the data points fall from the regression line. So you will have to look back into regression statistics terminologies to basically understand more of this. And if you're already from data science background, then you already know what I'm talking about. We are just seeing how Excel easily helps us in doing these things. Now, we can also look at observations here, which is basically the number of observations in our model, which is 7. Now, when we talk about regression analysis, and if we look at analysis of variance, that is your ANOVA values here. So we basically see DF, you have SS, MS, F, and significance F. Now, to understand these, so basically what we are doing is, or what Excel is doing is, it splits the sum of squares into individual components that give information about the levels of variability within your regression model. So when you talk about your DF, that's basically the number of degrees of freedom associated with the source of variance. You have sum of squares, that is your SS. So smaller the residual SS compared with the total SS, the better your model fits the data, right? Now, when you talk about MS, that's your mean square. You have F is basically the F statistic, or you can say F test for the null hypothesis. Basically, it is used to test the overall significance of the model. And then you finally have your significance F, which is the p-value of F. So when we usually talk about simple linear regression, the ANOVA part is not really used, or it's rarely used, right? But when we look at the significance F value, that gives an idea of how reliably or statistically significant our results are. So if significance F is less than 0.05, that's 5%, our model is okay. If it is greater than 0.05, we will have to better choose another independent variables, right? Now we can also look at the output of coefficients, and that's what we would want to look at. So you basically have your intercept here. So when you talk about your intercept, temperature, price of ice cream, so we know we are looking at our variables, and then we are also looking at our intercept, which basically gives you more details on your coefficients. So the main important thing when we talk about regression analysis is basically your coefficients. It basically enables you to build a linear regression equation in the form of y equals bx plus a, which I explained earlier. And then basically we can understand our regression analysis output better. Now, when we look at the residual output, which we are seeing here, so that gives you your observations, how many observations we have. It shows what is the predicted units sold, and then it also gives you your residuals. So we can compare the estimated and actual number of sold umbrellas based on the observation. So we have 11.209 here, and if you compare, that's basically 12. The second one is 15, and here it is 13.5. You have, and similarly, you can compare all the values of actual units sold and what our regression has predicted. So basically what we can do is we can compare these, and we will see if there is any difference or no, right? So obviously there will be, or there would be some difference, because independent variables are never perfect predictors of your dependent variables. And the residuals basically help us in understanding how far the actual values are from the predicted values. So that's what we see here in the residual section. So for example, when we look at this one, which is 11.209 and the actual is 12, we see what is the residual and how far is the predicted value from the actual value. So similarly, we can also look at the percentile values. So that gives you your probability output, and this is what we have in our graphs. So we have basically our variables. We are looking at our variables and also the units sold and the relationship between them. We can basically add in more details to this particular plot. And you also have normal probability plot, which is basically getting your values from your probability output here. So this is how you can perform a simple regression analysis. And now what you can do is you can, as I said, you can basically be looking at your scatter plot. You can be looking at your y and x and your r square values, right? But remember what are the variables which you are selecting, and then you can compare these with basically the values what you see here. So remember here I've chosen my both set of variables, and you can choose one variable and then basically see what is its impact on the response or on the target. So it's pretty simple here. You can add more details to your scatter plot or the plots what we have created, or some people prefer to do it using formulas. So basically, we have some statistical functions that can help you do linear regression analysis, such as you have linearist, you have slope, you have intercept, you have correlation, and so on. So basically, you can use these particular functions, and what you will have to do is you will have to basically go in for a function if that's what you would want to do. And then you can search for functions and say, for example, I'll just say linearist and say go, and here I have my function. So if I would want to really use this one, I can do that. What I will have to do is then select the variable. So if you just say okay, and that basically says your known y's, known x, your constants, your stats, and basically you can use the formula also. But we are not covering that here. Might be in the later videos we can do that. So just try out and perform some regression analysis and try to look at your different variables and try to interpret that. So that basically gives you an easier way of performing regression analysis using your data analysis add-in